What if you could rebuild the entire internet? Seriously. Not just a new app, not just another service, but the whole shebang, making it decentralized, truly secure, and basically unstoppable. Well, that's the absolutely massive goal of a project called the Internet Computer. And today, we're going to break down exactly how they plan to pull it off. It all really starts with this weird paradox that's right at the heart of Web3. The whole point is to have trustless systems, right? But if you look closely, so many of these supposedly decentralized organizations, well, they still boil down to trusting a few key people to actually get things done. So how in the world do we fix that? How do we bridge that gap between the promise and the reality? And look, the best example of this whole mess, it's DAOs, decentralized autonomous organizations. They were hyped up as the future of how communities would govern themselves, but in way too many cases, the reality just hasn't lived up to the promise. Yeah, this quote from the Definity Foundation, it just hits the nail on the head. A DAO can have a perfect, completely fair, decentralized vote. But if it all relies on some person to manually go and execute that decision, you've just created a huge, single point of failure. The second that decision has to leave the blockchain, the whole trustless idea just falls apart. And this is really where the dream hits a brick wall. We were promised these fully autonomous systems, but critical stuff still happens off-chain, by hand. We were sold this idea of trustlessness, but we've literally seen cases where a DAO's funds were spent before the vote to approve it was even finished. We wanted verifiability, but one DAO got tricked because of a hidden row in a spreadsheet. The lesson here is pretty stark. The moment execution moves off-chain, your entire decentralized model is at risk. So, if the core problem is that things have to leave the safety of the blockchain to actually happen, how do you fix that? Well, the team behind the Internet Computer came to a pretty radical conclusion. You don't. You can't just patch it up at the application level. You have to go way, way deeper and build an entirely new kind of internet where nothing ever has to leave the chain in the first place. And this wasn't some idea scribbled on a napkin over a weekend. This vision goes all the way back to 2015 with this concept of a world computer. It took years of hardcore research, some major funding, and the creation of the Definity Foundation before the Internet Computer's public network finally went live for everyone in 2021. So Definity's mission, look, it's got to be one of the boldest plays in tech right now. They want to build a blockchain that is so powerful it can host literally everything, all the world's software, all its services, all its websites, completely on-chain. The end goal here is to make the centralized cloud giants like Amazon Web Services, well, kind of obsolete. So let me put it this way. The Internet Computer, or ICP, isn't really trying to compete with other blockchains. Nope. It's aiming to compete with the entire internet as we know it. It's designed from the ground up to be this one single world computer where you can build and run huge, complex applications from start to finish directly on the network itself. Okay, but a world computer? That sounds a little like science fiction, right? How is that even possible? So let's get into the engine that makes this whole thing run. What's the core technology that powers the system? First up, we've got these things called canisters. And honestly, the best way to think about them is like smart contracts on a whole new level, like on steroids. A typical smart contract just holds logic, right? But a canister bundles up both the code and its own memory, its state. They're so powerful that one single canister can host and serve an entire web application. We're talking front end, back end, everything, directly to your browser, all of it running on chain. Now, this next part, this is an absolute game changer for actually getting normal people to use this stuff. It's called the reverse gas model. Instead of you, the user, having to pay gas fees for every single click, developers preload their canisters with a kind of computational fuel called cycles. So for you, the user, interacting with the decentralized app feels exactly like using a regular website. No more annoying wallet pop-ups, no confusing gas fees, all that friction that keeps your friends and family away from Web3, it's just gone. And get this, the efficiency is just mind-blowing. Storing 1 gigabyte of data for an entire year on the Internet Computer costs about $5. Just $5. To put that in perspective, on other blockchains, you could be looking at thousands, maybe even millions of dollars for the same thing. This is what makes it actually possible to build real data-heavy apps completely on-chain for the very first time. Okay, so the magic holding all this together is a really clever piece of tech called chain key cryptography. Let's break it down. First, the network creates just one public key for a whole group of computers, which they call a subnet. But, and this is key, the secret key isn't stored in any one place. Instead, it gets shattered into tons of little secret shares. Then, those shares get spread out across all the different computers in the subnet. So, for any transaction to get signed, a majority of those computers have to come together and combine their shares. And here is the brilliant part. The full secret key is never put back together in one place. It's security through some seriously radical decentralization. All right, so now that we have that tech foundation laid out, let's go all the way back to that first problem we talked about, those broken DAOs. The Internet Computer's answer to this is a DAO to rule all DAOs, a system they call the Network Nervous System. The Network Nervous System, or NNS, is basically the ultimate DAO. It is the permissionless, on-chain brain that governs the entire ICP network. Now, when the NNS votes to approve a proposal, it doesn't send an email to a dev team. It's not just a suggestion. The system itself autonomously executes the change directly on the blockchain. The human middleman, that single point of failure, is completely cut out of the loop. And we're talking about total control here. The NNS can upgrade the entire core protocol. It can onboard new hardware and manage the machines that run the network. It can spin up brand new blockchains. It can even change the economic rules of the system itself. And the best part, because every single decision is executed automatically, the network can evolve and upgrade itself seamlessly without all those messy politics and contentious hard forks that we see plague so many other projects. So, this whole system has been up and running for a few years now, but believe me, they are not stopping here. The vision is getting even bigger. The recently announced roadmap for 2026 shows exactly where this is all headed, and it's all about driving real-world adoption and pushing the boundaries even further. All right, three massive pillars really stand out here. First is on-chain AI. Imagine AI models that can be trained and run directly on the blockchain, completely free from the control of centralized tech companies. Then you've got chain fusion, which means talking directly to other blockchains like Bitcoin and Ethereum without needing to use those sketchy centralized bridges. And finally, there's Mission 70, a huge proposal to slash token inflation by a whopping 70%, making the token's value much more tied to actual use of the network. Okay, now step back for a second and think about what happens when you put all these pieces together. You've got unstoppable AI that can talk directly and securely to other major blockchains. What you're building is not just another platform. You're building the bedrock, the very foundation for the entire next generation of decentralized applications. And this really signals a huge shift, you know? The game isn't just about proving the tech works anymore. They've already done that. Now the focus is all about adoption. It's about becoming a real, honest-to-goodness competitor to the traditional cloud services from Amazon, Google, and Microsoft that we all use every single day. So if they actually pull this off, you have to ask yourself, what happens when the internet that you use every day is no longer in the hands of a few giant corporations? What happens when it becomes one massive, unstoppable computer run by us, the users? The implications of that are just profound.